In chapter 4, we saw that the cosine of theta on the unit circle was equivalent to x over r, and the sine of theta was equivalent to y over r. And this is what we're using when we convert polar coordinates to rectangular coordinates. So x is equivalent to r cosine theta, and y is equivalent to r sine theta. So in example 1, we're converting polar points into rectangular points. So x will equal r cos theta. So my r is -6, my theta is -120, and on my reference sheet I see that the cosine of -120 is -1/2. So I have -6 times -1/2, or you could just type cosine -120 in your calculator. So this gives me 3. My y-coordinate will be r sine theta, so that's -6 times the sine of -120. And -120 is equivalent to positive 240. So I know I have -6 times negative radical 3 over 2. And you can go ahead and evaluate these radicals when you're writing your coordinates down. So this will be positive 3 times the square root of 3, which is 5.2. So this point is 3, 5.2. Part B, x equals 5 times the cosine of pi over 3. So that's 5 times cosine of pi over 3 is 1/2. So that's 2.5. My y-coordinate will be 5 times the sine of pi over 3. Sine of pi over 3 is radical 3 over 2. So 5 times radical 3 over 2 is 4.3. So this point is 2.5, 4.3. For part C, let me scroll back up. My point is -3, 45. So my x-coordinate is -3 cos 45. So the cosine of 45 is radical 2 over 2. So -3 times the square root of 2 divided by 2 is -2.12. My y-coordinate will be -3 times the sine of 45, which is also radical 2 over 2. So I'll have the same y-coordinate. So this point is -2.12, -2.12. In the next couple of problems, we're going in the exact opposite order. We have a point in rectangular coordinates, and we're asked for the point in polar coordinates. Here, you want to give your answer in radians. So you want to make sure that your calculator is in radian mode when you're doing this inverse tangent process. In example 2, part A, in order to find r, I know that r equals the square root of 8 squared plus 10 squared. So that's the square root of 164, which is approximately 12.8. And the theta, I'm going to take the inverse tangent of 10 over 8. And I'm going to make sure that my calculator is in radian mode when I do that. So when I take the inverse tangent of 10 divided by 8, I get approximately 0.90. Now that's in radians. One thing that you want to be mindful of, what all of this is kind of talking about, is be mindful of where this point will be. So 8, 10 is somewhere over here in quadrant 1. So I want to make sure that my angle makes sense. For example, if I had come up with an angle that was way out here, you should realize that that doesn't make sense. 0.90 is less than half of pi. So you have to kind of make that connection between this rectangular grid, the unit circle, and the radians. Okay, so the inverse tangent that I found was fine. So my polar coordinate in part A is 12.8, comma, 0.90. In part B, same idea. R squared, or R will equal, negative 9 squared plus negative 4 squared. So that's 81 plus 16, the square root of 97. Which is 9.85. And then I'm going to take the inverse tangent of y over x. So negative 4 over negative 9. Now in your calculator, there's no need to type in both of those negatives. I would hope that you'd realize that that negative over negative is positive. So I'm taking the inverse tangent of 4/9. And my calculator spits back 0.42. So again, think about the reasonableness of your answer. Negative 9, negative 4 would be somewhere over here. This angle that we just found, that's here. That's not quite right. So what I need to do is add pi to that value so that I'm over here where I should be. So that 0.42 that you have in your calculator, add pi to it, and you get that theta is 3.56. So your correct answer would be 9.85, comma, 3.56. So again, be very, very careful about the reasonableness of your answer that comes back to you from your calculator. In this example, once again, I'm converting polar to rectangular and rectangular to polar. So the reason why, notice it makes a point about telling us that we are facing due east. Think about where east is. It corresponds to the polar axis. Okay, so that's why they're mentioning that. So now I proceed as usual. 6, 125 in polar coordinates, I'm going to convert to rectangular in part A. as 6 times the cosine of 125, which isn't on our unit circle, so we are going to have to use our calculator, comma, 6 sine 125. Now, before I go typing this into my calculator, I need to make sure that I realize this problem's in degrees. The last problem I did was in radians. You need to switch back to degrees, otherwise you're going to get completely messed up. So, watch angle measures. Make a note to yourself. So now that my calculator is in degrees, 6 times 125 cosine is negative 3.44, comma, 6 times the sine of 125 is positive 4.91. There's part A. Part B, we're converting this rectangular measurement into a polar one. So R, remember, is square root of x squared plus y squared. That'll be the square root of 40, which is equivalent to 6.32. And for theta, I'm going to do the inverse tangent of y over x, so 6 over negative 2. And since this problem is in degrees, we can keep our calculator in degrees. So the inverse tangent of negative 3 is negative 71.57. Now we want to make sure to think about the reasonableness of our answer. So negative 2 comma 6 would be here. Negative 71.57 would be around here. It's in the wrong place. So in my calculator, I'm going to add 180 to it, so that I'll be in the right place. So theta is 108.43. And my polar point, therefore, is 6.32, comma, 108.43 degrees. Here we're converting equations now between polar equations and rectangular equations. So once again, we're going to use that whole x equals r cos theta, y equals r sine theta, and kind of work with it from there. So this will become r cos theta squared plus r sine theta minus 3 quantity squared equals 9. As always, I can't stress enough, this is not r squared sine squared theta minus 9. You must FOIL this out. So now I have r squared cos squared theta plus r squared sine squared theta minus 6 r sine theta plus 9 equals 9. Well, what can I do here? What I can do is factor out the r squared from these first two terms, and hopefully your brain will remember something, as painful as it may have been. Minus 6 r sine theta equals 0. From here, I've got r squared times 1. Remember that this expression should be a familiar one. Sine squared plus cosine squared is 1. So r squared minus 6r sine theta equals 0. From here, I can move the 6r sine theta to the right-hand side and get r squared equals 6r sine theta. And what we're allowed to do here is divide both sides by r and get that r equals 6 sine theta. And then they're asking us to identify the graph of the rectangular equation. So back here, we just finished this stuff, that is a circle. So that means that in the polar grid, this would also be a circle. You might want to pause your video to get this all down so that I have room to do part B. For part B, we're starting in the exact same way. We have r squared cos squared theta minus r squared sine squared theta equal to 1. And then we have r squared times cos squared theta minus sine squared theta equals 1. And this is also an identity. It's a little bit less familiar, but if you look on your reference sheet on the right-hand side, under the double angle formulas, you'll see that cosine squared of theta minus sine squared of theta is equivalent to cosine of 2 theta. So I can use that. R squared times cosine of 2 theta now equals 1. And when we're writing polar equations, you'll notice that a lot of times the r is on one side and the theta is on the other. So we're going to divide both sides by the cosine of 2 theta. And what we have now is r squared equal to, and again, we got to think back to chapter 5, 1 over cosine of an angle is equivalent to the secant of that angle. So our final equation is r squared equals secant of 2 theta. It asked us to identify the rectangular, the graph of the rectangular equation. And again, we just finished doing these graphs. That is a hyperbola. Here, we're going in the opposite direction. We're rewriting the equation in rectangular form. So, looking at r equals -3, we know that r squared equals x squared plus y squared, so we can replace that r with the square root of x squared plus y squared equals -3. And then in order to get rid of that radical, we can square the whole equation and get x squared plus y squared equals 9, which you should be able to easily identify as a circle. In part B, I have the equation theta equals pi over 3. And one of the strategies that I mentioned was sometimes taking the tangent of both sides kind of helps us shift from thetas and radians into x's and y's. So I'm going to take tangent of both sides. So tangent of theta will equal the tangent of pi over 3. I know from my reference sheet that the tangent of pi over 3 will be radical 3 over 2 over 1 over 2. I know also from my reference sheet that the tangent of theta is equivalent to y over x. On the right-hand side of the equation, those two denominators will cancel each other out, leaving me with y over x equals radical 3. In order to make this equation look more like an equation that we've seen before, I'm going to multiply both sides by x. And so y equals x radical 3. So this is a line. And its slope would be radical 3. In part C, a little bit more involved. I'm going to multiply both sides by r. So when I do that, I'll have r squared equals 3r cosine theta. Now I happen to know that r cosine theta is equivalent to x, so my right-hand side can become 3x. On the left-hand side, I know that r squared is equivalent to x squared plus y squared. And if I bring this 3x over, I'd have x squared minus 3x plus y squared equals 0. Now, if you're looking at this equation and not quite knowing what to make of it, remember, you have a formula that will help you figure this out. Remember that b squared minus 4ac is something that we can use to figure out what kind of equation this is. So my b value is 0, since this equation doesn't have an xy term. My a value is 1, because it's the coefficient of the x squared term. My c value is also 1. So let's find b squared minus 4ac. That'll be 0 squared minus 4 times 1 times 1. That means it's a negative number. Remember, there's two things that it could be if it's a negative number. It could be a circle or it could be an ellipse. But in order for it to be a circle, my b value would have to be 0. My a and c value would have to be the same. Therefore, this is a circle.